All right, let's take a look at how we can prepare our ketones and aldehydes. Most of this is going to be review. We've already learned all of this. So one way we can do is through the oxidation of alcohols. So for example, if we have a primary alcohol, we could oxidize that into an aldehyde. Of course, we have to be careful of what choice of reagent we use, because if we further oxidize this, it will go to a carboxylic acid. With a secondary alcohol, that's not a big issue, because these will stop at a ketone, right? We don't have that other hydrogen to get rid of to go all the way to a carboxylic acid. In the case of, the oxidant where it'll stop to an aldehyde, that's a bunch of reagents, right? So that's our PCC or our DMP or our Swern oxidation. So you can use any one of them, probably one of the first two, just because it's less to write. Another thing we can do is we can oxidize alkenes. So for example, we could go from this alkene to acetone, right? So there's an example of that. If you think back how we did that, it was through the use of ozone, right? So ozonolysis, so add some O3. And then in this case, we want to stop at the aldehyde and not go to the carboxylic acid. So we'll add here as a reducing agent as opposed to an oxidizing agent. And so that'll end up with some aldehydes and some ketones, depending on your structure of your alkene, right? So for example, this side would end up as an aldehyde, whereas this side over here would end up as a ketone. In terms of the reducing agents that you can use here, you can use either dimethyl sulfide, or zinc. Zinc's another option. And if you think about why they're acting as reducing agents, so reducing agents will give up electrons and thus themselves become oxidized. So for example, dimethyl sulfide oxidizes with this little oxygen, and then of course zinc can become zinc 2+, and then it gives up 2 electrons that can be used to reduce this intermediate. If you think back to what the intermediate is, right, if you have some kind of alkene like so, when you add the ozone, it'll basically insert itself in between these bonds. Produce this intermediate. Then this kind of center oxygen goes with whatever the reductant is, and then these two oxygens become our carbonyls. Just a little bit of review. And then finally, last thing we could do is oxidize, not last thing, never mind. We could oxidize alkynes as well. So remember, our alkynes are our triple bonds. So if we have a triple bond, and then a triple bond, we can have one of two options, right? We could do this either in a Markovnikov or an anti-Markovnikov fashion. So for example, if we use sulfuric acid, water, and mercury sulfate, we would essentially kind of get the Markovnikov addition. So our ketone in this case would end up in the more substituted position, right? So this is number one, number two, number one, number two. If we wanted the opposite, instead wanted an aldehyde, we could use our BH3 in THF and then oxidize with some hydrogen peroxide and some base to get our kind of anti-Markovnikov addition. Be careful and make sure that you're drawing all your carbons. And then finally, last thing we learned was the Fetal-Crafts alkylation, or my bad, acylation. And so here, if we have a benzene ring and we add an acid chloride, we then add our ketone into our benzene ring. So just some review.